Okay, we'll skip to 22, 23, and 24. So when we're talking about kinetic energy, again, especially when we're relating it to gas, kinetic energy is the energy of motion. So we know that as those particles are moving, the higher the temperature are, the more kinetic energy they have. Okay, so when we say what is kinetic energy, it's the energy of motion. Okay, and specifically for this unit, we're talking about how those particles are moving. Okay, what causes gas pressure? Well, gas pressure is going to result from billions of collisions of gas particles. So, billions of collisions of gas particles. Okay, so the more collisions between those gas particles, the higher the pressure you're gonna have. So the amount of gas could cause it. A smaller container could cause those particles to collide into each other, and also with the container more. Okay, so those collisions are what's causing that gas pressure. And then number 24, at what temperature would the kinetic energy of the gas be the slowest? Okay, well, the lower that the temperature is, the lower kinetic energy is going to be. So you could say as temperature decreases, your kinetic energy will decrease. Okay, so as temperature increases, kinetic energy will increase. So if I'm looking for the gas to be the slowest, I'm going to look for the lowest temperature. Okay, so we know that 250 kelvins is the lowest temperature out of all my answer choices here. Okay, and so 250 kelvins is where the kinetic energy would be the slowest. Okay, question 25, mixture of oxygen, carbon dioxide, and nitrogen has a total pressure of 0.97 atmospheres. What is the partial pressure of oxygen if the pressure of CO2 is 0.7 atmospheres and the pressure of nitrogen is 0.12 atmospheres? Okay, so for this one, you're using Dalton's law of partial pressure. Okay, and we know that partial pressure is just the total pressure is equal to all of the parts. So P1, P2, P3, and so on. Okay, we could have multiple pressures. With this one here, we just have three. Okay, so oxygen, carbon dioxide, nitrogen to get your total pressure. Well, it says the total pressure is 0.97 atmospheres. Okay, and we know that CO2 is 0.70 atmospheres. Okay, nitrogen is 0.12 atmospheres. And then what is the partial pressure of oxygen? So we don't know the pressure, the pressure of O2. All right, well, it's pretty easy to solve that. If I'm just solving for this part, okay, I'm going to add these two together and subtract from the total. All right, so just so you can kind of see it, you've got your 2.70 plus 0.12, okay, is 0.82. Well, I'm going to subtract that from the total. So I would subtract that 0.82 from this side here, okay, which is going to equal my pressure of oxygen. So 0.97 minus 0.82, 0.15. Okay, so the pressure of oxygen is going to equal, we said 0.15. Okay.